All right, welcome back. Hope you all have had a nice break. Are there any questions? Any questions? All right, so before the break, we did a moving average. Now we are going to do exponential smoothing. So we did that, moving average. So this exponential smoothing, we are going to use example 4.5 in the textbook. Okay, it is all the calculations. We are going to use Excel to facilitate the calculation process, but you also need to understand the formula. Okay, the sum formula. So this data 4.5, the data is 4.5. It is here. So 4.5. Try to locate the data for this one. Table 4.7. All right, so this is the data. Okay, this one here. So it is about sales. It is about sales data from year 2000 to year 2006, and it is quarterly data. So year one, you have quarter one, quarter two, quarter three, quarter four. This is year two, quarter one, quarter two, quarter three, quarter four, etc. Okay, what you are asked to do is, so first of all, examine the data by creating a line chart to explore the data patterns. Okay, so to do that, you select the original data and the time. These are the original data. Just double check focus period. Yeah, this is the data. Did I miss anything? Number 6. And then you go to insert, chart, line chart. Okay, so this is the data. Looks like the data is not stationary, non-stationary data. Okay, and the data have ups and downs, cyclical effects, and the data also looks like has the seasonal effect. Okay, so once we have the idea about this data, you could use, what we want is to put more weight on the recent data when we build the model. So that is the characteristics of exponential smoothing. Okay, take into account only the most recent observation. Okay, so to do that, we need to use the formula. Okay, so the formula here, the general formula. I'm going to write down. Okay. So the formula said, if you forecast t+1, if you want to do t+1, and you are given a constant, we call that constant is alpha. Okay, alpha could be any number between 0 and 1, okay, and then use YT data plus 1 minus alpha times YT hat. Okay, this is an example. For example, if you want to forecast for period 4, t equal to 3, this formula becomes this formula. This is general formula. General formula. And if alpha is 0.1, okay, you plug in 0.1, y is 3, you go back to original data, y is 3. Y3 is 250 here, Y3. Okay, 250 is Y3. And then Y3 hat, you need to do the Y3 hat. So to do Y3 hat, you copy this formula again, Y3 hat equal to 3 equal to 2 plus 1. So 2 plus 1 hat equal to alpha y2 plus 1 minus alpha y2 hat. Use this formula. So alpha is 0.1, y2 is 350 here. This is y2. See where's my mouse? Okay. And then y2 hat. Okay, y2 hat. So you need to go back to y2 hat. In this exponential smoothing, we do the initialization, initial value. So we do y hat 1 equal to y2 hat equal to y1. So y2 hat equal to y1, it is 500. And you got this 485. Once you got this 485, that is a forecast for y3. You plug in here. We need this y3 hat here. And you get forecast for y4 hat. So you keep on going. You keep on going. Okay. So that is the formula. And do the calculation by hand. It is all here. I explained it. And now, how do I use Excel to realize this formula? Okay, so this is the point I'm going to go to. So those are the original data. Alpha is given, is a smoothing constant, 0.1. And then I'm going to, how do I calculate y hat? That is the question. So I'm going to delete all of this. Okay. Delete all of this. And then remember this is y1 hat. Y1 hat, by definition, it is just y1. Okay, y1 hat equal to y1. This is y2 hat equal to y1. Okay, and now next one, you need to refer this general formula here. Next one, we need to use yt plus 1 hat equal to alpha times yt plus 1 minus alpha times yt hat. So when you forecast next period is referred to t plus 1, the data you use for t. When you forecast t plus 1, you use data for t period. Okay, so this formula equal, okay, alpha. So this is my alpha. And this alpha is constant. So I'm going to change to absolute cell reference. The reason is I need to copy the formula. So you press F4 button, function F4 to change to absolute reference. Oops. So equal alpha, then change to absolute reference alpha. Alpha times yt. Okay, this number 350 is yt because we are forecasting t plus 1. When you're forecasting t plus 1, you use t. Okay, this is alpha yt, and then plus 1 minus alpha. Again, alpha is absolute value, and times the previous forecast is this number, yt hat. I pause for a moment to see if you have any questions for this one. Any questions? Where did you get K from? Sorry, I missed this question. This is a previous question. Okay. Sorry, I missed that question. The previous question, where did I get a K from? It is from here. 3-week moving average. So K equal to 3. If it is 4-week moving average, K equal to 4. And if it is a 5-week moving average, K equal to 5. Okay. All right, so that is the question. Any other questions? So this formula, what I did, this formula is based on this formula, yt plus 1 hat alpha yt plus 1 minus alpha yt hat. In Excel, I type in the formula here. I press OK button. Once I use this formula, the forecast for other numbers, I just copy down. That's it. Exponential smoothing. Okay, I copy down other numbers, and you can double check with the textbook. Let me double check. Yeah, the number agree with the textbook numbers if you check those. Okay, and once you get this y hat, you can calculate the forecast error, EI, forecast error. It is just use y minus y hat, y minus y hat, that is the forecast error. Okay. All right. So any questions? Any questions? So that is the exponential smoothing. Okay, exponential smoothing here. Okay, I did example 4.5. 4.5. Okay, now let's do some problem from chapter 4. Okay. So the question is at try to locate the page number. Page 138. Question 1, I'm going to copy this so that we can make annotation. Here. Question 1, which forecasting technique continue revise and estimate in the light of more recent data? Any idea? It is just the example we did, exponential smoothing. So question 2. Which forecasting techniques use the value for the current period for the forecast for the next period? Anyone? Oops. Naive model. Okay. Question 3. Which forecast assigns equal weight to each observation? Equal weight for each observation. That is the moving average. Moving average. Moving average. Question 4. Which forecasting should be tried if data are trending, either trending up or trending down? This one you can use two parallel smoothing procedure. Okay, means double smoothing. Okay. Question 4. Question 5. Which forecast technique should be tried if data is seasonal? We haven't tried, we haven't have the, this one for now, you just need to have some concept about techniques. So we are going to introduce this technique next class, okay? It is Winter's. Okay. Winter's method and also smoothing, etc. All right. Okay, question 6. Question 6, the data is from table P6. So I'm going to get table P6 data. So chapter 3, problem 6. Do I have that data? No, this is chapter 4 data. So go to chapter 4, problem 6. Here, problem 6. So this is the data. I'm going to copy and paste. Control C. Go to problems. This is chapter 4. Problem 6. Problem 4 and then 6, P6. All right, so what is the question here for this question? So this is the price and each month for 12 months. Question A, so we are doing question 6 now. Question A, find the forecast value of mutual funds for each month by using a naive model, using equation 4.1. Equation 4.1. Okay, so remember equation 4.1. What is equation 4.1? It is y hat. Double check 4.1. So next period, t plus 1 hat. Okay, to forecast next period, you just use the previous period or current period. So t plus 1 is next period. How do you forecast next period? Use current. YT is current. Okay. All right. So the value for December 2005 is 19. 2005. What is that? 19. Okay. So after you copy this data, I'm going to copy this data into next location. Okay, never mind. Okay, so I need to insert a number. Insert, because the question said the value for December 2005 was 19. The number for 2005 was 19. December 2005. So this number is 19. Okay, 19. So after that, I will do the forecast. Y hat is the forecast. So the next number is the previous number. That is the naive method. And then you double click, you get all forecast. Okay. So we completed A, step A. And step B, evaluate the forecast using MAD. MAD. Remember what is MAD? MAD is to calculate the difference. So what I'm going to MAD to calculate the difference between original observed number and the forecast number. And take absolute value, ABS, take the absolute value. And then do the average of all these numbers highlighted. That is the MAD equal AVER do the average. Okay, so that is MAD. And next, calculate MSE. Calculate MSE. So how do you calculate MSE? You do the square. Okay, YT minus YT hat and square it. YT minus YT hat and then square. Okay, and do this for all the numbers. Then take the average of all these numbers. So that is MSE. And then do MAPE. Okay. So MAPE. The formula, I'll try to recall the formula. So MAPE is to take the difference between YT and YT hat, take absolute value divided by YT hat, YT divided by YT, absolute value. Then add them all divided by N. Okay, so that is a MAPE. MAPE. So how do you do that? MAPE. MAPE. Okay. Equal to do absolute value ABS YT minus Y hat divided by ABS YT. Okay, that's it. And then copy down the formula. After that, take the average of the number you get. ER. So that is MAPE. MAPE. Any questions? Okay. So last one, MAPE, then MPE. Okay. So MPE. What is MPE? MPE, you use YT minus YT hat without absolute value, and then divided by YT. Take the average, sum it all, and divide it by N. So that is MPE. So now I'm going to do MPE. MPE. Yeah. So equal to bracket Y minus Y hat divided by YT. Oops. So YT minus YT hat divided by YT. Copy down and then take the average of all this number. So those results I will highlight it is the answer. Okay. Those are the answer for those measurements. Any questions? Just maybe copy this. So this is question 6. All right. Question 7. Question 7.
And sorry, can we go back to number G? What would be expected for a memo summarizing this?
Write a memo, summarize your findings. Okay, so this one, it is just you write a few sentences. For example, actually you just report from the forecasting value using the naive method. The summary means first you state what method you use. So this question you use naive method, okay? And then you report the result of this MAD, MSE, MPE. That is the summary, okay? So first mention the method, forecasting method you use, and then report those numbers. That is your summary. Any other questions? All right, so next question, question 7. Question 7. Use a 3-month moving average to forecast the price for January 2007. Okay. Is this forecast better than using the naive model? There are 2 questions in question 7. Okay, so January 2007, it is here. This number is January 2007. We are asked to forecast this number. I'm going to use maybe fair color. So forecast this number. This is January 2007 using 3 months moving average. So I'm going to type in here 3 months moving average. 3 months moving average. So 3 months moving average. So depending on if you want to use this number is given. Okay, so you use this number, this 3 months average forecast here. Some students or some textbook want to put a result here. Okay, it is actually does not make big difference. So let's say I want to put result here. Okay, do the 3 months moving average. So you do equal AVERAGE. So 3 months. This is 3 months moving average. And then you double click, eliminate the decimal places. Okay. So this is 3 months moving average. And then using 3 months moving average for January, this number, so I have go to 1 cell down, continue moving. Oops, let me redo it. Yes, so the moving average for January is 22. This last number is the result for, is the answer for this number here. Okay, moving average, 3 months. And then, what is the second question? The second question asks you, is this 3 months moving average better than using naive model? Better than or worse than? To answer that question, what do you do? How do you know which forecast is better? Any idea? How do you compare naive with the 3 months moving average?
Do you take the forecasting errors of both to see which one is better?
Thank you so much. You need to calculate those measurements, MAD, MSE, blah, blah, blah. Okay, to see which one is smaller. The smaller the number, the better the forecast technique. So let's do MAD for 3 months moving average. So remember, this time I'm going to speed up, okay? So remember what is a MAD, okay? MAD, you just take absolute value of the difference between YT minus YT hat, take absolute value. So ABS, this is Y minus Y hat. Okay. Then copy down. Okay. And then do MSE. MSE is YT minus YT hat square. And then copy down. And then MAPE, it is ABS, ABS Y minus Y hat divided by ABS YT, and then copy down. Lastly, do MPE. MPE equal to Y minus Y hat divided by Y, and then copy down. Okay, and you have to do the average, AVERAGE, average of all this number, then drag to the right. Okay, so compare this number. So I'm going to put it in another color. Compare the number with the blue background with the number here, with maybe gray. Okay, compare those numbers. Let me see. Three moving average, MAD has smaller value, and then MSE has a smaller value. So looks like 3 months moving average has a better forecasting capacity because those values are better than, smaller than those values. Okay. Unless I didn't double check my, let me double check my calculation. MAPE, mod 0.9 MSE. So the method is let me double check ABS square. Okay, so that is this question. Okay, question 7. So in summary, what we did today, we go over some questions from chapter 3. Okay, chapter 3, exploring data patterns, auto correlations. Then we moved on chapter 4. In chapter 4, we did moving average and exponential smoothing. We haven't finished chapter 4 yet, so next time we will continue with chapter 4 and then start chapter 5. Okay. Any questions? That's all for today. Any questions?
I'm still a little bit confused about the applicability of the MAD, MSE. Are those values, do they mean something on their own? Could I just run the first batch and say it's 0.743, or is it only in relation to comparing 2 different methods?
So here we use 2 forecasting techniques. Those are naive method, and these are 3-week moving average. So when you compare, for example, MAD with MAD, we hope the smaller the value, the better the forecasting technique.
Okay, so I wouldn't just be able to run it just for the naive and make sense of those values. It always has to be in comparison to, you know, against the 3-month rolling average figures as well. Like, it doesn't mean anything on its own.
Good question. If you don't make a comparison, you just do the naive. Is there any meaning for MAD? The answer is yes, there is meaning for MAD. The meaning for MAD is that it is measure the forecasting error, the accuracy of your forecasting. Okay, it has meaning. because we are giving 4 different measurements. We are saying, can you measure this forecast error using MAD? You say yes. What is the result? The result is 0.7. Can you measure the forecasting error using MSE? Yes, the result is 0.7, etc. Okay, so those MAD, MSE, etc. themselves have meaning. The meaning is it is like the accuracy between the real number, the number observed, original number, and the number you forecast, the error term. Okay, thank you for your question.
I'm sorry, I've got a lot of follow-ups here because this concept's kind of confused me a bit. So is there a number we should be aiming for with these, or is it kind of an absolute or relative value?
Those are absolute value. So for example, this MAD for naive method is 0.743. This is absolute value, not relative number, unless you compare the MAD from naive model with MAD from 3-week moving average. Even if you make comparison, you are compared two absolute value. So you are compare 0.743 with 0.498.
Okay. And then in terms of like overall applicability, so I'm a mature student doing this in my after hours, and I'm trying to think of how I would explain this to my boss, who is a sales guy. You know, what would be the practical explanation for I'm using naive because of this reason, and I'm using 3-month rolling average? Like, how would you kind of take those numbers and best describe it?
Good point. So to answer that question, you have to translate some technological jargon into some language normal people will easily understand. In this case, if you say naive, your boss may not understand because they are in the management position unless they have this kind of expertise. So depending on what level, what expert knowledge level your boss is. If he is an expert, go ahead, use naive, use 3-month moving average. If this person is just general manager, just use plain English, you telling them, okay, for this forecast, I have 2 methods. One method is based on simple method. The other method is those 2 methods are all simple methods, but they are different methods. And when I compare the errors using these 2 different methods, I found the second method is better than the first method. So I would use the second method, just telling them this. If the person is expert, you need to tell them the naive model, 3-year moving average model. Okay. Thank you for your question. Any other questions? Okay, that's all for today. Remember, you can always email me for any questions you may have. Please allow 2 business days to have your email answered. Thank you so much for your participation. Take care of yourself, both physically and mentally. Bye.
Bye, Professor. Have a good
Bye.
night.
Thank you.